Welcome, Mr. Sutton, bringing you the Pre-Cal Honors 4-3 Part 2 homework solutions on logarithms.
For this problem, we want to take log base 81 of 3. We're asking, what do I need to raise 81 to in order to get 3? And since 3 is smaller than 81, we're going to have to raise 81 to a fractional exponent. So which root of 81 is going to give us 3? Well, that would be the fourth root. So this is going to be the 1/4 power. So then log base 81 of 3 is 1 over 4. On this problem, I'm trying to find log base 13 of the sixth root of 13. I'm going to rewrite this just to make my life a little bit easier. Instead of writing sixth root of 13, I could rewrite this as 13 to the 1 over 6 power. And now I'm essentially asking, what do I have to raise 13 to in order to get 13 to the 1 over 6? Well, I have to raise 13 to the 1 over 6 to get 13 to the 1 over 6. So that is 1 over 6. Another way you can think about this is when you have the same base in the log as you do in the argument, those bases cancel and you just get the exponent. For this problem, I'm asking what is the log base 4 of 1 over 64. So basically 4 to the what power gives me 1/64. Since this is a fraction here, a 1 over situation, this is going to be a negative exponent. 4 to the third is 64, so 4 to the negative third would be 1 over 64. So then our answer is -3. On number 4, we need to simplify this logarithm. If you don't see a base on the logarithm, then it's an invisible base 10. So we're basically asking 10 to the what power equals 10,000. Well, there's 4 zeros here, so that would be 10 to the 4th. On this problem, we're asking for the log base 1/2 of 1 over 16. So we're asking, what do I have to raise 1/2 to in order to get 1 over 16? That would be the 4th power, so this comes out to 4. On this problem, I want 12 times the natural log of e to the 5th. So we'll do this natural log part first, and then we'll multiply the answer by 12. So I'm asking basically e, because that's the base here, e to the what power equals e to the 5th. And whenever you take ln of something with an e, you just get the exponent. In this case, e to the 5th equals e to the 5th. So we're doing 12 times 5 then, which is 60. For this problem, we want to take the ln, which is the natural log of 1 over the 4th root of e. So I think it'll be easier if we rewrite this as e to some power. Since this is 4th root, we have an e to the 1/4 down here. And since it's 1 over e to the 1/4, we can rewrite this as e to the negative 1/4. So if we're asking for the ln of this, we're essentially asking, since ln is base e to the what power equals e to the negative 1/4. And that's just going to be the negative 1/4 power. For number 8, we're asking 64 to the what power would give me 2. So this one's kind of tricky because 2 is not an easy to see power of 64. It's a root of 64. It is the 6th root of 64. To get the 6th root, we need the 1 over 6 power. For 21, I'm taking the ln of 1 over the square root of e. To make my life a little bit easier, I'm going to rewrite this as e to the negative 1/2 power. And then when you ln e, you're basically just getting rid of the e and getting the exponent, because here I'm asking e to the what power is e to the negative 1/2. Well, that's just going to be the exponent, negative 1/2. For number 10, we want to know 5 to the what power equals the cube root of 5. This one's a little bit easier to do if you convert this to a fractional exponent. So this is really 5 to the 1 over 3. Now we're asking 5 to the what equals 5 to the 1 over 3. Well, clearly it's 1 over 3, and we're done. For number 11, we're going to take care of this logarithm part first, and then we'll multiply it by the 36 here. And it'll be a little bit easier to do this if we make it a fractional exponent. So this is really 11 to the 1 over 12 power, if you have the 12th root. Now we're asking 11, base 11, to the what power equals 11 to the 1 over 12. This is a case of so easy it's hard. 11 to the 1 over 12 equals 11 to the 1 over 12. So you then have 36 times 1/12, which is just 3. For number 12, I'm asking, what do I have to raise 5 to in order to get 1 over 25? Well, 1/25 itself is 5 to the 3rd, So 1 over 125 is 5 to the negative third. For 13, I'm asking what do I have to raise 1/3 to in order to get 1 over 27. So that would be the third power. For number 14, I'm asking what do I have to raise 2/5 to in order to get 4/25. So I have to square the 2 and the 5, so that would be the second power for this one. For 15, I'm asking what do I have to raise 4 to in order to get 1 over 256. Well, 4 to the fourth would give us 256, so 4 to the negative fourth would give us 1 over that. On 22, I'm raising 10 to the log base 10 of 88. Well, log base 10 of 88 is the thing I have to raise 10 to get 88. So if I raise 10 to that, the 10 and the log base 10 just cancel, and I just get 88. For 23, I'm raising 6 to a log base 6 of 31. If you have the same base here and in the exponent log, then those just cancel, and you just get the number inside the log, which is 31. For 24, I'm raising e to the ln of 875. This is like having a base and the same base in a log in the exponent. In that case, those are just going to cancel out, leaving me with the number inside the log, 875. For this problem, we're trying to figure out 11 to the log base 11 of 22. So what we're essentially doing is taking this expression here, log base 11 of 22, which is the number I need to raise 11 to get 22. We're taking the number I need to raise 11 to get 22, and we're actually just raising 11 to that number. So when I do that, I'm going to just end up with 22. So what's happening here essentially is these bases are canceling. So we just get whatever is inside the log. For this problem, we're trying to raise e to the power of ln of 100. Now, I have no idea what ln of 100 is numerically, but what it represents is the number I need to raise e to get 100. I don't know what that number is, but if I raise e to the number I need to raise e to get 100, I should just end up with 100. Another way of saying this is that the bases are going to cancel. We have e and we have log base e of 100, so that just gives us what's inside the logarithm, which is 100.